Hello everyone, and welcome to your second Cocoa Concurrency tutorial. In this tutorial, we're going to be covering a little more on threads and some issues related to multi-threaded programming. And to tackle the issue that we discovered in the first intro video, we're going to talk about a concept known as locking. And we'll do that in sort of two different ways, and hopefully that'll explain the concept of locking to you. So, where we left off in the first tutorial, you'll notice that we had two separate threads trying to run the increment val 1000 method, and in that example we noticed that different values could occur, right? There was never really any defined value that kept reoccurring. There's no real consistency, and of course the reason for this is that two separate threads are trying to access the same piece of data at the same time. They read and write at different times though, and so therefore you can have these very different values depending on when each thread gets to run. So that is the issue that we face. Now, a way that we can resolve that is using what's known as a lock. And the way I like to describe locks is sort of with a bathroom analogy, which some people may dislike, but I think it describes it quite well. So let's just say, for example, you were in a mall and you need to go to the bathroom quite urgently. And so you go and you find a stall, and you go there and you lock it, right? So you go to do your business and you lock the stall, and you are going to be the person using that specific toilet for this period of time. And presumably you only have one person in the bathroom at the same time, because if you don't, that's probably kind of weird. But the point being, right, is it's you lock the door and you do your stuff, and then you unlock it hopefully when you're done. Otherwise you just, evaporate it through the walls. So hopefully you lock it when you go in and you unlock it when you come out. Now, if two people were trying to get to that stall at the same time, right, they were both trying to use the bathroom at the same time, bad stuff could happen. And that's what we see when we have threads, right? Both threads are essentially using the bathroom at the same time. They are changing the values, or getting val and reading it, writing it at different times, and then it's a mess. So that's essentially the same idea with the bathroom, is that one person will hopefully acquire the lock on that stall. They will use the bathroom, and then when they're done they'll unlock it and the other friendly fellow can use the stall. So that hopefully will clear up any analogy ideas that you don't understand. So how can we actually accomplish this? Well, there's actually a number of ways that you can use locks in Objective-C. There's probably about 5 different ways really to accomplish the same thing, but some of them do different things. So I'm going to only show you 2 different ways though in this tutorial, but they should at least get the concept across. So there's 2 functions that we can use. For this first example, we can use Objective-C sync enter, and this is sort of the locking start. This is where we're going to say start the lock, and we pass in some object that kind of represents what we're going to be locking on. And in this case, we're locking on self, or the class that we're going to change. And I'll talk a little bit about that in just a bit, but let me just write some more stuff here. Objective-C sync enter is what we have to start with when we want to acquire the lock, and Objective-C sync exit is what we use when we want to exit. Now, the very important part is that you are locking and unlocking the same thing, right? If we unlock different objects, then that's not good, because we're not talking about the same thing anymore. It's like if you were in one bathroom stall, you lock the door, and then you teleported to the end stall, and then you unlock that. It doesn't help you out, right? So you gotta be able to unlock and lock the same thing. So make sure you are doing that. Now, with that said, what does this really mean? What does it mean when we lock self? Well, we're not really locking the entire object. So if somebody else came along and just wanted to read the val, it could do that. It could do really anything it wants. All this really means is that we can't access the code that's between here and here. So what this code essentially translates to is, hey, we want to lock this specific section. We're going to use self because it kind of makes sense. We're changing stuff in our object right now. We could make another object and lock that, but there's really not much of a point in this example, we want to say don't touch self at this point. If you're trying to change something specific to self, then don't do it right now. Again, though, this doesn't mean that somebody else could come in. We could have another thread, and it could just change val for no reason. And if it's not going through this specific block of code, it's really not concerned with it. And I'll do a little demo at the end to clarify that point. But again, the real important part is that this block of code between the enter and the exit are going to be locked, and only one thread is going to be accessing it. So if you think of the thread as the person trying to access your bathroom stall, then the thread really is that in this example. Two threads are trying to run this whole block of code here at the same time. However, only one person will actually be able to acquire the lock. So whoever wins this battle of calling this function first, they will be able to acquire the lock, and they'll be able to run this code. And then whenever that thread is done, they'll exit or they will unlock, and it allows other threads to go. So what happens when we allow one thread to go through, if the other thread also comes here around the same time, but he doesn't win, maybe he doesn't get the lock in time, then he's going to sit here. He's going to sit at this function, and only one. He just has to wait until it exits. So that's sort of an issue with locking, and that's why you usually want to make locking as short as possible. You want the code between locks to be really as concise as it needs to be, because if it's not, then you've got you're locking for a very long period of time, which means one thread has to wait until this other thread has completely executed this code, and then it gets to run again. So you really want to minimize the amount of code that you ever put between locks. So really, we wouldn't want to have a print statement probably in between any type of locking, unless we're just debugging. So in this case, we're just debugging our code, so it's really fine. But in the case of most locks, you'd want to try and minimize the amount that goes through. All right, so if we run this now, the moment of truth that you've all been waiting for, you notice that we actually get 2000, and that's the appropriate behavior that we expected in this example, because we did expect that only one thread will be able to change this val or really execute this code at the same time. Alright, so that's one thing. Another thing that you'll note is, which is very important, is that if we never exit, we never unlock ourselves, or we never give up the lock that we've acquired in the first place, only one thread will ever be able to execute this. So one thread will actually go through this a bunch of times, and it'll be fine, because it was able to synchronize self, meaning that basically, the thread that originally gets this, it's good to go. It can run this all day long. However, if it never gives up the thread, or it never gives up the lock rather, then nobody else can actually ever use this code. So, which is not good, right? We would prefer that we can actually let somebody else use this at some point in time, because otherwise that means that the other thread is stuck at this point. It'll never get off this point, and that's that's an extremely you would not want that to happen in an actual application, or else you've got one thread doing nothing, but it still has to sit there. All right, so that's an example of locking. Now another way that you can get doing this is use an NSLock object, and this is from Foundation. And we'll just make a simple object here. We'll call it lock, and we'll just simply initialize an NSLock. Now, an NSLock works very similarly. It has two functions that we can use, and if we actually look this up, we can command click on NSLock, and we can look at some of the things that it has. So we'll notice that it adheres to the NSLocking protocol, so we have both the lock and unlock functions. There's actually a few things that you can do with the lock as well. You can name the lock, which can be useful if you have multiple locks, or you're trying to address which lock you're actually talking about. You can look up the name or set the name of that. And then there's also these different methods for actually trying to acquire the lock, which is fairly useful. If you are trying to acquire the lock and then you don't get it, then you could actually, in theory, try to do something else. So these are different functions that you can use. There's also different kinds of locks. These two are different types of locks that you would use depending on the case. But there's different options that are there. However, we're just focusing on this NSLock example for this tutorial, and more specifically these two guys, the simple lock and unlock functions, or methods I should say. So what we want to first do is we want to lock, and then we want to unlock. Alright, and this basically works the same way as the first one does. We don't have any explicit object that we're doing, but the point being is that this lock object works the same way as saying that we're going to synchronize self. So really it means that whoever has access to this lock at this time will have access to the lock, right? Instead of using the self object like we were doing before, we're really saying this specific lock is going to be locked, and you can only, one thread will win when it tries to acquire this. Alright, so if we go ahead and try to run this, you'll notice that, congratulations, we also get some proper output. The neat thing about NSLock though is that it can be aware of locking more than once, and it doesn't let you do this. So if we try to lock, and then we try to lock again on the same thread, you'll actually get a deadlock. So you'll notice that we printed out the first thing, so somebody acquired the lock, we were able to print out this line, but then when it went to go and lock again, it actually gave us an error of a deadlock. And what deadlocks are is essentially when you've stopped everything at the same lock. So what that means is that the first thread, whoever won this trying to acquire the lock, it was able to go through, and the other guy had to sit here, right? And then when we went back through again with the thread that actually acquired the lock, and then it tries to lock itself again, then or really acquire the lock I should say, then it can't do that because it already acquired it. So this is kind of safeguarding you really against this case, right? It means that you have to be careful, and you really should unlock as soon as you've started unlocking, as soon as you've acquired or you're done working with the code that you need to work with. So the deadlock case is where both threads are sitting at the same spot and both are trying to acquire the lock, but neither of them are going to win because it's already been locked. So it's like you locked the bathroom stall, but somehow you managed to disappear out of the bathroom, and it never was unlocked. So then anybody else that tries to actually go to this point is now stuck because you locked the door on them. So that is a nice little feature of NSLock that you get, and that's locking. So it's a fairly simple concept, and it is a way that you can prevent important parts of code that are trying to be manipulating shared resources, which is our val in this case. And if you want to protect against those, you can use a lock. Now this isn't really always the best way to go about it, but again, this is sort of an intro video on explaining how these concepts work. But with that being said, I'll show you one of the downfalls of trying to use an approach like this that, again, is one of those issues that we fall into with concurrency in general. Now, if I made another function, I'm just going to leave those locks in there for now. But let's say I make another function, and this guy is going to be called increase pal. And I'm just changing the name for the sake of changing the name, and I'll get rid of the locks in this case. Alright, so in this case we had the locks, and I'm just going to take, whatever, I'll leave that in there, and we have our print. That's cool. And one of these threads is going to call this method. Alright, so one of these guys is actually locking this block of code, and we're manipulating val. So if everybody just called the increment val method, we'd all be good, and we'd never have any problems with our val. However, we made this other function called increment pal, and it's also actually going to increment val though, but it doesn't do it without any locks. So the problem here is that because there's no locks, we are still free to try and access or change what's in val. So if I go ahead and run this, we'll see that we're not actually safeguarding ourselves from anything now. We are back to the same problem that we had before. So this is just demonstrating some of the benefits of locks, but also the downfall of locks as well. Just because we lock a specific block of code, it doesn't mean that we've actually changed the mechanism of which we've incremented the value, right? So just because we've locked this block of code doesn't mean that another block of code can come in and change value at the same time. So again, these are all the little tricks that you need to be aware of when you're working with concurrent code and the weird expected things that might happen, or the unexpected things, I might say. Alright, so anyway, this is again just sort of a tutorial to cover a very important concept called locking. If you have any other questions or are really interested in some of the other locks that are available, feel free to leave your comments in the comment section below, and I will see you in an upcoming tutorial. See you then.